Alright, hello everyone. So in the last video we derived a formula that we can use to find the volume of an object that you get after rotating a curve around the x-axis. The formula is x1 x2 pi fx square dx. Now let's use this formula to solve some problems, actually couple of problems, and then I'll show you what to do if we rotate a curve around the y-axis. So in this question we have the function y is equal to x cube and we are rotating it around x-axis. The curve is bounded by the x-axis, x is equal to -1 and x is equal to between x is equal to 2. So those are the limits, right? The curve is going from -1 to 2. Okay, that's the range of the x value. So pi, and you're rotating around x-axis, so it's pi fx square. The function is x cube, so it's x cube square dx. That's the idea. It's super simple. So it's pi -1 to 2 x cube square is x to the 6. 3 times 2 is 6. So this is the integral. Now in these problems from now on I only set up the integral. Okay, so we discussed in previous video series how to integrate functions. We have done that enough. The focus of this lesson is to how to properly set up an integral that can find you the volume. Okay, so I'm gonna stop there. I hope you know how to integrate x to the 6. Right, the third question, well, the second question in this video, but overall third question is, now we have the graph of 2 square root x and it's bounded between 1 and 4. Now you're rotating this around the x-axis, so we need to find the volume. Okay, so what do? The x limits are going from 1 to 4 and pi fx square, the function is 2 square root x, so square it. That's it. Okay, so pi 1 to 4, so square of this is 2 square is 4, square of square root is x, and this is it. This is the integral, and 4x, again, it's an easy integral to solve. I'll not do that here. Okay, but that's the integral that will help you to find the volume of the object that you get by rotating the curve 2 square root x around the x-axis. Right, so now let's look at this problem. So you have y is equal to x cube bounded by y-axis. Y values are now going from 1 to 8 and now you're rotating it around the y-axis. Okay, now this is different from previous problems. Previously we rotated stuff around the x-axis. Now you're rotating it around the y-axis. So let's try to visualize this. So here's the same curve. Now if I rotate this around the y-axis, you can see you're making bunch of copies of that curve around the y-axis. Here we go. Here's your 3D object. Okay, so now you can see when you create this 3D object, you can see we still use the idea of disks, but the thing is that we now have a horizontal disk, not a vertical disk. Okay, so when we were setting up the formula for stuff that we rotated around x-axis, we took a vertical disk and we said, okay, the height or kind of like the width is delta x. Okay, but now since we are rotating around the y-axis, now our disks, they are going to be horizontal disks. But no matter whether you have horizontal disks or vertical disks, the formula doesn't change. It's pi r square h, the area of the cross-sectional part and times the height. Okay, so cross section is still a circle, doesn't matter whether it's vertical or horizontal, so the volume is pi r square h. But the thing is that now the height is, we keep it the same, but it's now delta y. We partition the y-axis. So when you're rotating a curve around the y-axis, you partition the y-axis. Okay, because now the disks are horizontal, so this is going to be your h, so that means you are dividing the y-axis and you keep it same, so delta y. Okay, so now you set up the integral with respect to y when you're rotating around y-axis. This is important. So it's still the same formula. Okay, now it's the y1 to y2 pi dy. Now the radius is the important part. So the center of the disk is actually going to be the y-axis. So what's the radius? Radius is where the function meet, right? See, the radius changes. So where do we meet the function? So the radius is in fact the function. That's what I'm going to say. But you can't say it's fx because now you are integrating with respect to y. So what you need to do is you need to rewrite this function where x is the subject, or you have to rewrite the function in terms of y. So it's going to be gy square. Okay, so the only difference here is that when you rotate it around the x-axis, rotate a curve around the x-axis, the volume is pi limits of x, the function written with respect to x squared dx. So that's if you rotate it around x-axis. But if you rotate it around y-axis, the limits belong to y. The function should be written in terms of y because now you are integrating with respect to y. Okay, and the radius is now the function itself but written in terms of y when you're rotating around y-axis. Okay, so that's the thing that changes. All right, so let's do this example. Now you're rotating around y-axis, y limits, see, y values are going from 1 to 8. So 1 to 8 pi dy. So those things are easy to write. Now what's the function? So function here is y is equal to x cube, but you can't use that. You can't say this is x cube square because now you're rotating around y-axis and you set up the integral in terms of y. So you need to make x subject. So y is equal to x cube, and I can write this as x is equal to, you can take the 1/3 power of both sides. So x is equal to y to the 1/3 power. So it's y to the 1/3 power squared. Okay, so you make the x subject. So when you're rotating something around the y-axis, a curve around the y-axis, and you want to find the volume, you have to rewrite the function in terms of y. I think we did this when we were doing the arc length lesson, and also when we were doing the area between curves, and when we were setting up the integrals in terms of y. Okay, so let's simplify this. So this is pi 1 to 8, y 1/3 to square is y 2/3, 2/3 dy. So this is the integral that will give you the volume of the object that you get by rotating the curve around the y-axis. Okay, right. So I'll do a couple more examples in the next video, and then we can jump into a different topic but the same type of problems. Okay, in fact I think I can do another problem in the same video and jump to a new harder topic in the next video. Okay, so now we have the function y is equal to 1 over x. You're rotating it around the y-axis. That's the key thing. And the y values are going from 1 to 4. So y values are going from 1 to 4 pi. You're rotating it around y-axis. So integral set up with respect to y. Now the function is y is equal to 1 over x. But that's not good. You have to write it in terms of y. Make x subject. So multiply, so cross multiplication, take x to the left by multiplication, take y to the right by division. X is equal to 1 over y. So that's the function, that's the radius. So 1 over y square, that's the integral. So I can simplify this, pi 1 to 4, 1 over y square is 1 over y square, and solve this integral and it will give you the volume. Okay, I'm not going to solve this integral. As I said, we are just setting up the integrals. That's what we are learning in this video series. Okay, right, now I can, in the next video I can discuss a new topic. It's kind of like the extension of the same idea, but we are getting into some tougher problems.